Hello and welcome to the segment 2 of the AI malware analysis. In this segment we're going to be talking about AI-based static malware analysis. Now I probably need to include an introduction of what are the different types of malware analysis, but until I get to that video, there are basically a few different types. Static analysis is one type. Then you have dynamic analysis, you have hybrid analysis, and you have behavioral analysis. Each one has its own specific advantages and disadvantages, it's a video on its own. So I'm going to record a different video on that. If you're interested in that kind of content, then subscribe to the channel and you're going to get a notification when I get to do the video, possibly today, possibly tomorrow, who knows. But let's talk about what is static malware analysis. Actually, before we move into what is static malware analysis, introduction about myself. So hold on, that's the video YouTube channel. Here is the link to my YouTube channel. I'm just uploading the video that I've recorded now. This is AI School Oxford, and I record videos in preparation for trainings that I'm delivering. So this is in preparation for my training, which is tomorrow on AI-based malware analysis. So that's happening tomorrow. If you're interested, you still have time to subscribe to the O'Reilly webpage. Most large corporations and universities have free access. This is published by Pearson. If not, you can subscribe to my channel because quite often people would see this video after the course is finished. And in that session, I'm going to be talking about Gydra. So I'm going to be recording a video on how to use Gydra. Gydra is a reverse engineering tool for malware developed by the NSA. It was classified until 2019 and now it's been declassified. We're going to be talking about Snook, Deep Code AI, how to integrate Deep Code AI to your GitHub. When you're writing code, it will dynamically scan for malware in the code. We're going to be talking about Black Mamba polymorphic malware, which actually I have recorded video on Black Mamba already in the past. We're going to be talking about Cuckoo Sandbox, which you can do static and dynamic analysis, Vector AI, CrowdStrike, hybrid analysis, and here is my Google Scholar profile. You can find most of my work, most of my papers. They're open access, freely available. You can read them. The University of Oxford has paid their open access fees, which is around £3,000. So it's quite an expensive way to publish, but universities have these policies on making it open access, and all of these papers are open access, which means if you click, you will be able to read the work. You don't have to register or pay a journal subscription, which quite often happens with other types of research. More about me. This is me. I work for the University of Oxford. That's my webpage, staff webpage, which I need to update. I haven't updated this webpage in a long time. There's also a second webpage, which is Find an Expert. This is part of the University of Oxford, and it talks a lot more about selected publications, expertises, yada yada yada, all those things that some people might want to know about me. And again, if you want to read my work, it's free and publicly available. But if you prefer to watch YouTube videos, then subscribe to my YouTube channel. Now going back to the actual content of the presentation, static malware analysis. In this half-an-hour session, hold on, let me set the timer because I keep forgetting that the sessions need to be timed. And again, this is in preparation for my recording tomorrow. So I have 8 segments of sessions, so this needs to be not more than half an hour. And in this segment, first we're going to start with a theoretical overview of AI-driven static analysis tools, advantages, but also limitations. So there's a reason why we have different types of analysis, and static analysis is just one type of analysis. Actually, if you're performing cybersecurity analysis, you need to be quite advanced with all of the different types of analysis, not just one. We're going to try to detail what's the difference between malware and polymorphic malware. So step by step, hopefully by the final session of these videos, you're going to be very clear in the differences between polymorphic malware and normal malware, and why future of malware it's mostly going to be polymorphic. for which, unfortunately, you need to have more of a dynamic approach to analysis than static analysis. So for this video, I will try to do a demo of static analysis with Deep Code AI, but to be honest, on my YouTube channel, I do have a video, if I can find it, videos on that specific topic. Hold on, there it is. So as you can see, there's already recorded video on static analysis with Deep Code AI. So I'm gonna try not to expand too much on that in this video, because you can always go and watch that video. And then we're gonna try to understand more about Black Mamba. But again, I do have also a video specific on Black Mamba. So that's why we're gonna talk about other things in this video. What other things? What is the difference between static analysis tools and their advantages, limitations? So the definition first of static analysis. It's analyzing malware without executing it. So you're analyzing the malware without putting it in a sandbox and running the actual malware. For reverse engineering, there's various different tools. You can use disassemblers like IDA Pro. And this is getting to the borderline of religious beliefs, that some people prefer IDA Pro, some people believe different types of disassemblers. Each one has its own favorite. I'm not going to get into that. I use all of them. I prefer to use the open source because I don't have licensing for the paid ones. And in these videos, I'm going to be explaining why some of the paid versions are better, but I hardly ever use them because I don't have licenses. So with static analysis, you can perform code inspections. You can analyze the malware binaries. You can perform string extractions. You can identify hard-coded values. And you can perform hash comparisons for file signatures. So the advantages and limitations of this approach. Static analysis is limited. Hold on. Because encryption techniques are used more and more by malware. So advanced malware would have strong encryption techniques and you won't be able to even analyze it with static analysis. What are the famous tools? And here again we have links. So when I click on that, it's going to take us to those specific types of tools, and I'm going to do that at the end. But let's first understand what they are before we click and review the actual tools. Static analysis, the classical tools for analysis includes IDA Pro. It's a shortcut for interactive disassembler, and it's a widely used tool for reverse engineering. Ghidra is also used for reverse engineering. There's various different tools for reverse engineering. It's not the only one. And with this tool, you can disassemble binaries and you can create an assembly code representations. So PATE is used to detect the packer, compiler, or cryptor used in the PE or portable executable files. And with Binwalk, it's a tool that is used to extract informations and files embedded within binaries. And often this is used for firmware analysis. A real-world example of when this type of analysis, static analysis, was performed, it's WannaCry. It's a very famous hack, and analysts were able to identify the embedded kill switch in the domain, in the malware binary, that when activated, it stopped the ransomware from spreading. So there you are. Static analysis has its own benefits from time to time. And let's click on these links just to see some of these tools. Now, I need to go into the full screen mode. I keep forgetting to do that. IDA Pro. Let's look at IDA Pro. This is IDA Pro. It's a disassembler, an all-in-one tool. It has some functions that are very straightforward to use. Obviously, setting it up is more important than actually using. The usage for all of these disassemblers is quite intuitive. It has debugger inside, and you can produce these beautiful windows that's going to map how the analysis is performing. Runs on Mac OS, runs on Windows, runs on various different even Linux systems. So you can run this. It's one of the most popular tools. And you can automate your analysis. So here you can connect it with the API, and you can connect it with IDA Python, so it has additional API libraries that you can use. And this is in a nutshell IDA Pro. Let's see what do we have paid. This is the plugin for paid. It detects most common packets and compilers for PE files. It can detect more than 600 different signatures in PE files. And paid is special in some respect when it's compared to other identifiers. And here is a whole list of reasons how it's different. I'm not going to read those. I'm just going to provide you with a link. So if you wanted to see what's the difference between this tool and other tools, obviously here you're going to have the differences. And there are 3 different scanning modes in paid. Now, let's look at the detect packer. So this is related to cryptos. So if you're into cryptocurrencies, paid has installation for that as well. And for me this is interesting because I work a lot with decentralized AI. So I'm looking at how one day AI will become fully decentralized and go out of control, create the next technological singularity event. So this is the detect tool that I use quite often because I work in cryptos. Third example, it's Binwalk. So let's look at Binwalk. So this is the GitHub repository, which will have some kind of a demo, but it's a firmware analysis tool. It's written in Rust for speed and accuracy. What can it do? It can identify and extract files and data which have embedded inside of other files. So this is the primary focus of its firmware analysis, to extract files and data that have been embedded in other files. And how to get it? The easiest way is to build a Docker image. So that's it. Again, that's going to be a good half an hour, more than half an hour demo, which we won't really have enough time to do this in this video. But it's relatively easy to build a Docker image. And again, if you're interested in that, then subscribe to the channel. And then when I record that video, it's going to notify you. But in this video, we're going to be covering many more tools. So IDA Pro, starting from IDA Pro, looking at paid, the code of paid for crypto, and this is just one more tool, Binwalk. So let's see, what else do we have? Static analysis of WannaCry. Static analysis of WannaCry. WannaCry was a cyber weapon powered ransomware worm. And here you can find the detail. Let's see what kind of code do we have here. As always, liability disclaimer, read that. The maximum extent permitted by law. There's a disclaimer that using this, use it at your own risk, basically. To be infected requires SMB port 445 to be open, or if the machine is already infected, then if the kill switch is not registered or somehow blocked, the network accessing through it is a proxy. So here is a whole list of infections where WannaCry has managed to infect, and some of those are the NHS, Nissan, and although most of these hacks are designed by Russians, and there's a reason why even Russians are not happy with them, because you see, it hacked the Russian Interior Ministry, it hacked the Russian railroad, it has hacked the Russian bank, it hacked a secondary school in China, it has hacked the country public security bureau in China. So it had a very diverse attack vector. So and that's why eventually everybody was upset with the WannaCry. but it was identified using static analysis of the malware binary. Now, with this one, here I would be doing the exercise with Deep Code AI. Again, if you're interested in the exercise on Deep Code AI, this is it. You can find the video on YouTube. It's recorded 6 days ago as part of my prep work. And there you can follow it step by step. That video is specific for the Deep Code AI. Hold on, let me just click and pause it to see how long. 45 minutes. So that video took 45 minutes to record, and obviously the video session that I'm recording should be not more than 30 minutes, which means that it's going to be difficult to implement that kind of example. But what it entails, it's basically, here's the Deep Code AI. Just to run you through it, you need to sign up, and then you need to log in to sign up. You can sign up with your Google account or with your GitHub. So I did sign up with my Google account, and once you're signed in, there's a specific list of steps that you need to do to connect your Snook with your GitHub. And then once it's connected, every time you write the code on a file, it would automatically be scanning and giving you a push notifications. So you can actually even set it up to send you push notification through social media. So it will send you a message when a vulnerability has been detected in your code. And the reason why it's important is because quite often we just copy and paste code. We don't write all the code. And this vulnerability is in the code. So with Snook, you can analyze the code that you're writing. They have a free version and they have a paid version. So the demo that I did here, it's using the free version. That's not the paid version. But anyways, so for this one, I do have a second version of this, which is on, hold on, Deep Code AI. Let me open Freeform, and I'm gonna Deep Code AI duplicate. Let's see if it's duplicated on my iPad. It's been duplicated on my iPad. Now I'm gonna screen share the iPad, and I'm gonna try to explain it quickly on the iPad. And again, if you want to watch the full demo, there it is. It's been recorded already. 45 minutes on step-by-step process on how to use it. Now let's talk about this in the iPad. If I can screen share MacBook Pro. There we are. So now we should be moving to So Deep Code AI. What do I have on Deep Code AI? Why is it important that we use things like Deep Code AI? What color should I use? Blue. Okay, let's stick to blue. Let's increase the... So when you write code, most of the time people think that they're just writing lines of code, and that's how we do actually write lines of code. But what you should be doing, and this is a software engineer thinking, that this is the full job from a security engineering perspective, so cybersecurity engineering perspective, you need to be writing code that is secure and reliable, not only to be writing code. And this is where sometimes these two fields, they diverge. So security and software engineers, they have different opinions because writing secure code adds steps. So you need to do more steps in order to build your code. With just writing code is very straightforward. And quite often when you copy and paste code, you don't do any security checks of the performance of that code. And that's why software engineers are quite often upset with security engineers, because we keep adding these layers and layers of bureaucracy, what they see. And with Deep Code AI, or Snook, it's one thing now, it's one company. You can analyze vulnerabilities in the code, in the dependencies, in the container, or in the IAC automatically. So Snook is doing all that for you. You don't have to do it manually. And this is where the two fields of software engineering and security engineering can kind of merge and be happy chappy all together. because it's not that the software engineers, they don't want to write secure code. Quite often they lack understanding of cybersecurity. They're just very good developers. They're not very good security analysts. And many of the security risks that you would explain, they wouldn't even compute to them as a security. And if you can have tools like Snook that would automatically do all the work, then obviously everybody is happy to do it. How do you perform static analysis with deep code AI, and how do you reverse engineer polymorphic malware using deep code AI? Remember, what is happening here is that Snook is automatically looking for vulnerabilities, and as soon as they are detected, they are being reported. So that is quite priceless. Although it's considered static analysis, it has a dynamic element that is doing this automatically. And obviously the code itself, contains viruses and malware. The dependencies would contain malware, the containers would contain malware. There's various different layers where the malware could be infected. The trick is that Snook can do all those analysis independently, but you need to set it up. So in the example that I provided, I've set it up for code analysis, and then you need to add a different command code to run for dependencies, container, and IAC as well. So starting from the first slide, analysis of models and datasets. So here you would have hybrid AI models. You have various different models that graph neural networks, for example, variational autoencoders. And I can go through all of those with the deep code AI. So let's start with the hybrid model. Deep code AI employs a combination of symbolic AI and generative AI, and this is what they're very proud of. So the symbolic AI and generative AI are not easy to merge together, and they have, in their hybrid model, they have been able to merge them. For example, here, what do they use? They use BERT. BERT is bidirectional encoder representations and transformers, or variations of CodeBERT. They're adapted to understand the syntax and semantics of programming languages. So those models are trained on massive data spaces to build an understanding of programming patterns and common coding practices. Now, when you're looking at the second, so that's the first step, the second step, graph neural networks are used to model the relationship between code components such as functions, and the relationship between dependencies and control flows. So by constructing a code graph, it identifies how different parts of the code can interact and highlights anomalies. And one example here is that it can analyze a polymorphic malware, which usually introduces a deceptive function calls, or usually it modifies the control flow to conceal its true origin. So GNN can detect these irregularities by tracing the execution path, and it can identify deviations from normal paths. So that is how GNNs would help. Variational autoencoders, those are used for anomaly detection by establishing a baseline of normal coding behaviors trained on datasets like GitHub or open source repositories. Variational autoencoders are also used to identify deviations from expected patterns, such as excessive nested logic or unusual obfuscation techniques. So that is the third step, and the fourth would be the datasets. It has extensive dataset content utilization. So GitHub Code Corpus, it's one, which is consistent of millions of licensed open source repositories. And those are used to train the model on secure coding practices, and they provide baseline for detecting anomalies. Second would be the National Vulnerability Database, which is cross-referenced to identify known vulnerabilities, enabling the tool to pinpoint executable weaknesses in the analyzed code. And third would be the Ember dataset, which is a specialized malware analysis dataset that is used to train the deep code AI model to recognize malicious behaviors. And in terms of language support, I found on their webpage that they support up to 19 programming languages, including Python, Java, JavaScript, C++, Ruby, and many others. So this means that probably they have some value for all of us. Now, I'm not going to go through all of these different slides that they are listed here because we have 1, 2, 3, 4 slides, and it's possible that I have gone through these slides in my previous video, which is specific on deep code AI. So this is just a reminder that if you want to find out more about deep code AI, you can watch that other video. To avoid repetition of content, I'm gonna stop the screen sharing now, and if I can find that code, I can refer you to the specific. So this is it. So this is the static analysis of Snook with deep code AI. And here, as you can see, I'm going through these examples in very much detail. I'm not going to be going through all of those again because that's just pointless. If you're interested in this kind of content, you can either subscribe to my YouTube channel on AI security, or you can subscribe to the O'Reilly Digital Library and watch the full 4 hours recording, which is going to happen tomorrow. So I'll see you in the next video.